This is okay, right?
Yeah.
Dear students and faculty members, it's my great pleasure to introduce today's guest speaker, Dr. P.S. Harikumar, Senior Principal Scientist and Head of the Water Quality Division, Center for Water Resources Development and Management, Calicut. Dr. Harikumar earned a PhD in the Department of Applied Chemistry, Cochin University of Science and Technology, and a postdoc from KTH Royal Institute of Technology, Sweden. His research areas are water quality management, environmental monitoring, water treatment, wetland studies, urban water management, nanotechnology, microplastics, etc. He has been a research officer in the Indian Petrochemical Corporation Limited in 1992, and then he joined as scientist and presently as senior principal scientist in the Center for Water Resources Development and Management, Kerala. He has supervised several PhD, MTech, and MSc theses. He has also completed many sponsored and consultancy projects, and few more projects are also running currently. Sir has published 47 research papers in reputed national and international journals. Also, Sir wrote several book volumes as well as book chapters on water management. Dr. Harikumar sir has been member of several national and international bodies, including member of International Water Association, member of Board of Studies for various subjects of Calicut University, also member in the committee constituted for formulation of state waste management policy by government of Kerala, to name a few. With this very brief introduction, I would like to invite Dr. Harikumar sir to start the presentation. Welcome you, sir. Thank you very much.
Okay. Thank you, sir. Thank you for a nice introduction and respected professors and my dear students. Today, I'll be talking on maybe a topic which may be very relevant for today's time because as you know that our water body is getting polluted due to several reasons. No, our population is increasing, a lot of pressure from the maybe urbanization. So all these are actually putting a lot of pressure on this our water bodies. Not only with regard to drinking, our industrial sector is also having its own maybe pressures from a lot of things. So what I'm doing is that I will be giving a maybe a lecture on how to actually in fact treat this type of water bodies which are contaminated or polluted. There are several methods are there, but which some of these things my dear students you may not be familiar, and what I am actually focusing on those kind of things which some of these things already we did a lot of maybe pilot programs in our institute, and which I will be sharing with you what are the things which have been already been done. That's actually in fact that is my objective in 1 hour or 1.5 hours. Anytime you can actually stop my presentation, you can ask any questions, no problem. And whatever I know I can actually share with you the details, and if you are very keen I can share some of the maybe details also. So I am sharing my slide. I think it is visible now. Is it visible? So my
Not
topic
now.
is actually, is it
No,
visible?
no.
No, sir.
You have to share, sir. Share it, sir.
Yeah, now
Whether
fine. Yeah.
Okay.
so So I'm presenting actually before you one of what are the technologies which is available in drinking water treatment and also in other sectors also, especially with regard to industrial or maybe municipal effluents. There are a lot of methods are available. We'll be consolidating all these methods which lot of traditional and modern methods are there. Now, water treatment actually, in fact, this involves not only drinking water, but municipal water has to be treated, and before it is actually reaching any water body, or again industrial water. There are a lot of pressures on industrial water also to treat it and discharge into the water bodies. Otherwise, all our water bodies will be polluted, or maybe it can have its own pressure on the ecological characteristics of these water bodies. So coming to the major water quality issues which India is facing, that is which are both common to surface and groundwater, are pathogenic bacteria, especially if it is fecal coliforms are there, that's a big problem. Salinity, and wherever actually we have a coastal areas, salinity is very important in the respect to our rivers and also with regard to our groundwater also. There are so many places where actually the water body is susceptible to the salinity problems, especially if you go deeper and deeper in groundwater. When you are actually not getting the water, you are actually digging the well to a maybe more than 200 meters also. So that may cause the salinity issues also. In many states we have that type of problem. Then of course toxicity due to micropollutants, that is maybe different types of metals or maybe other type of organics. Then again coming to industrial pollutants which are being discharged without any proper treatment, that also causing the problems. Coming to surface water specific problems are of course eutrophication. All of you may be knowing that what is eutrophication, because there are you can see that there are so many places you can see unwanted growth of this maybe weeds will be there, that will be resulting in the oxygen depletion, and again that will be affecting the ecological health also. Then groundwater, there are issues like fluoride, nitrate, arsenic, iron, and seawater erosion is also taking place with regard to this groundwater. So these are some of the general issues of India, but again there are some local issues are also there, which we will be coming across from maybe differently from state to state or maybe region to region. So because of this problem, the government of India or maybe international bodies, they are actually in fact set certain standards for drinking water before you are actually drinking the water, which include there are so many parameters are there. For example, BI standards are is the actually in fact the major standards which in India we follow, and latest one is IS 10500 2012. There are 36 parameters are actually listed in this BIS standards, which starting from color, odor, turbidity, pH, total dissolved hardness. So what is actually the importance of this type of IS standards are there? Once actually in fact you are testing the water, if all these parameters are within this acceptable limit only, then you can actually drink the water for maybe without any type of problem, including health or maybe aesthetic problem. That is the importance of this type of standards. Again, there are standards set by ICMR and CPHA also, but that is not that much important. We are actually following the standards, especially by Bureau of Indian Standards. That is actually, in fact, it's a very important. Again, cyanides, lead, anionic detergents, polynuclear aromatic hydrocarbons, residual chlorine, pesticides should be absent, coliforms should not be there, E. coli should not be there. These are actually, in fact, selected kind of things, but altogether there are 36 parameters are there. There are certain radionuclides are also there listed in the Bureau of Indian Standard manual. So you can actually refer that type of things. Then if you are actually testing the sample in the laboratory, you have to be very careful that these are absent or within this particular range or acceptable limit in your water which you are consuming. Otherwise, there can be a problem of aesthetic or maybe other type of diseases like maybe fluoride if it is more than 1 milligram per liter, you will be getting fluorosis. Nitrate, if you are actually consuming the water of more than 45 milligram per liter, you will be causing methemoglobinemia. And again, there are certain type of lead is a very toxic kind of a thing. If it is more than 0.1 milligram per liter, that may actually cause some problems with the nervous system also. So these are some of the limit or acceptable limit in drinking water, which we have to be very careful. So what we'll do actually, in fact, maybe with regard to some of these parameters, if it is present when we are testing the water sample, if it is present in excess, you have to do some treatment methods. So that's what I am actually talking today with or sharing some of the things with you today. So again, when you are actually discharging the effluent, general permissible standards are the effluents should be having a pH of 5.5 to 9. Total suspended solids should be less than 100 milligram per liter. Oil and grease should be less than 10 milligram per liter. BOD less than 30 and COD should be less than 250. So these are some of the permissible limit with regard to these effluent standards with this actually when it is before discharging into the inland surface water. So what we have to do is that the effluent also you have to test, and if it is more than this kind of particular values, you cannot actually in fact discharge it into the public sewerage system or any type of water body. And you can have some litigation problems also. There are bodies like everywhere we have this pollution control board units are there, and they can actually take action those who are actually discharging their effluents beyond this type of limit. Coming to the drinking water, first actually we will discuss about how actually in fact this drinking water can be treated now. And the important thing is that actually the drinking water should be very clean and free of contaminants before we are consuming. That is what we call it as a potable water. So if any problem is there, we have to do some water treatment to remove the contaminants or bring down the contaminants to the desired level. That is actually important when the water is getting polluted or maybe it is getting contaminated. There are so many traditional methods or the maybe starting from very long historically there are so many methods have been used, and coming to the drinking water in general it should be free from pathogens, should be clear with low turbidity, little color, not saline, free from offensive taste or free from compounds that may have adverse effect on human health. So that is all actually depending on our this Bureau of Indian Standards. That is mainly depending on this type of with things which when we are actually drinking the water. So that also should be free from chemicals that may cause corrosion of water supply system or stain cause washed in it. Coming to what are the methods which we can adopt to improve the water quality, that is actually there are so many methods are there. We'll just mention some of these treatment methods which are available. When you are actually going through the literature available now, one of the ancient, one of the best, first method which have been reported is actually incident in which had happened in Egypt. What they were doing is that they are actually collecting the water in maybe large drums or something like that, which they are actually siphon out by some soldiers, and that is maybe getting some pure water. So the thing is that it's a general kind of method. When you are actually decanting the water, the heavier particles will settle and the whatever actually water it will be clarified, and that water is getting siphoned out. That is actually what is being done by these Egyptians when in old times. Again, there are so many maybe Sanskrit writings which mention that people were actually using certain maybe heated iron that is being dipped into the impure water, and that is getting pure also. That is what is actually the people were doing. And again, in all the literature, not only in our own Hindu Veda or something like that, there are in Bible or even Quran also There are some mentions about how the water can be purified, or they actually purified the water. Like even Moses and the Israelites, they actually came to Mara. They found that water is actually having a very bad taste. So what they did was that they actually put certain tree or banks of tree into that particular water, and the water was actually sweetened. That is a kind of a things, and later it was found that that type of a tree has some ability for some ion exchange properties are there with that tree. Again, there are some mention about using cloths to purify the water. So coming to general methods of this water treatment are: one is screening, then aeration, coagulation, sedimentation, filtration, and disinfection. These are some of the methods which we are actually following. I'll be coming to one by one. Screening is actually nothing but using a screen with a small mesh size so that the larger particles cannot pass through that type of a screen. That is actually simply the screening of this turbid water or impure water, which is having a lot of other particles also. Aeration means nothing but passing the air through the water, which is found to be purifying the water, then oxidizing the many compounds, especially organic compounds, and iron. Iron, especially, that is actually purified by using aeration, because iron in the form of a dissolved state will become converted to ferric form, which is not soluble in the water, and that will be precipitated. These type of things also can be removed by this aeration. Again, it will promote the good bacteria growth, and that will be helping to purify the water also. Sedimentation actually, in fact, which includes the removal of particles by flocculation, we can actually remove the sediment particles. You can see that there are so many instances are there where actually the water is getting having lot of impurities also. Then what we are doing is that we are adding certain coagulants and that will be trapping the impurities, and ultimately it will be precipitating out and trapping the impurities, and that will be settling to the bottom. That is what is happening. And there are so many types of coagulants or flocculants are we using. One is actually acrylamide, then aluminum chloride, aluminum sulfate, bentonite, catenite, polyacrylamide, ferric chloride. All these are some of the maybe coagulants which we are using. But general type of a thing is actually, in fact, alum we will call it as, that is aluminum sulfate, which generally we are using to coagulate the water. And if you can actually put this powder in a vessel which is having a high turbidity, then you can see that after some times now the turbid particles will be settling down. Then you can actually maybe decant the water and or filter the water through certain filter media. Then you can use the water. Even there are so many instances where people are using this aluminum sulfate to their put into the turbid water body. After that, sometimes the whole water will be getting maybe cleared. So these are all actually very good coagulants, which several industries are also using this type of flocculants. Filtration is actually the purification using sand, charcoal, gravel, etc. We are actually packing these type of materials as a filter media, and if you are actually passing the water through this type of filter media, ultimately we can see that the water is getting maybe purified. Again, coming to disinfection, that again I will come to later. And this is actually a general kind of a treatment methods which is being practiced in a water treatment plant. Like maybe when water which is not or a very pure water, or maybe contaminated water, polluted water, first it is to be passed through a screening method, and whatever impurities are, that will be screened. Then in fact it is being coagulated using a certain coagulant. Normally we are using alum only for as a coagulant. Then ultimately this will be having a system of filtration using slow sand or rapid sand filtration. Then again it will be kept for some time so that the sedimentation will be taking place, and ultimately then finally disinfection will be taking place using a chlorine dioxide or a chlorine gas, or even bleaching powder will be added. And ultimately that will be treated, and we are actually storing it in some type of maybe storage devices, and from there actually it is being supplied to the public also using that method. There are so many simple water purification methods are there, like boiling, settling, filtration, sunlight exposure, three-pot treatment. So boiling means if you are or if you found that your water is contaminated with the E. coli bacteria or a fecal coliforms, then the best method is actually boiling the water for 5 to 10 minutes. So you should actually see that that should be boiled a minimum of some 5 minutes up to 10 minutes. Then that will kill almost all the microorganism or even a harmful bacteria. So that way you can actually purify the water, or from the microbial contamination you will be able to actually remove this type of pathogens. Filtration is nothing but using even a clean cloth also can actually pass the water through that type of porous media. Ultimately, that will be purified using this type of cloth. Settling, already we discussed that if you are going to have a vessel and you add some turbid water, ultimately we can see that the all the particles will be settling down, and you can actually transfer that water into another vessel, so that you will be getting some good pure water. These are some of the pod systems which you might have studied in your school classes also. There are supporting media, different types of media which we can use: sand, gravel, charcoal, bleaching powder. Still in so many villages, people are using this type of method to purify their water. So it's a maybe a relatively good method to purify the water where advanced technology is not available. Again, in so many countries or so many states, they have a method of using certain plant materials. For example, moringa seeds. You may be knowing that what is moringa in the picture I had shown here, and from that seeds actually, in fact, it is actually acting as a natural flocculant and coagulant. So it is one of the best method to water can be used for water purification. So what is happening is that it has to be either pulverized, or we can actually take that maybe that particular pulverized kind of a media. Then it has to be added to the contaminated water. Then that be acting as a coagulant. Then it is precipitating and trapping the impurities. Then we have some disinfection method also, like boiling of water, then chlorination, excess lime, iodine and bromine, potassium permanganate, ultraviolet radiation, ozone. So all these are actually different types of disinfection methods which we are using in different type of actually to remove the pathogenic bacteria. So the main factors which we are maybe using are actually in fact affecting us in killing range of microorganism. These are some of the criteria by which you can actually select a particular maybe disinfectant. Then again, a potential to form possible harmful disinfection byproducts. So if you should not form any possible harmful disinfection byproducts, like chlorine, if you are adding, there are chances of maybe trihalomethanes formation. So we have to be very careful that we are actually using less chlorine when you are actually disinfecting a water. Chlorination, in fact, it is one of the health risk which is reported in European and US countries. But the thing is that we are still using because we don't have the alternatives for removing the pathogenic bacteria. Then we have actually chloramines when ammonia and chlorine are added in water together. This is actually having a maybe advantage of having a very long lasting kind of impact will be there when you are adding chlorine with ammonia. So that's the advantage with the chloramination. Then ultraviolet disinfection. This is one of the best method which now maybe side products are being formed. So it is does not produce the chloroorganic byproducts. Then biocide effects are instantaneous. Then a small space is actually required, and the absence of toxic chemicals make UV one of the best method also. But the only thing is that the time period which actually the impact will be lasting is a very less compared to the chlorination. That's one of the disadvantages of ultraviolet disinfection. Ozone is also having the same effect, but it can also control the taste and odor. But normally we are actually, even though using the UV, ozone is generally used in a swimming pool, that type of water bodies, and it will actually prevent the formation of organohalogen compounds. Then it can also be used for the removal of iron and manganese. Then again, this Sodis technology. Sodis technology is nothing but we are actually keeping the bottles and over the roof for sunlight, maybe up to 5 to 6 hours, and that is actually a kind of maybe impact, or maybe using this sunlight exposure. It is having UV radiation, so that this bacteria will be killed by this type of methods. The advantage that can kill a harmful bacteria, simple, convenient, and inexpensive, and it not change the taste of maybe chlorine also. And again, chlorine, how actually in fact we can use the chlorine is that we may have to use 2.5 gram of bleaching powder for 1000 liters, and this has to be actually formed as a slurry or something like that. Then you can just add the maybe required water. Then the have to clear solution need to be added to the whatever water body is there, like or open well or whatever may be. So then we can actually kill the bacteria. So they can actually used after 4.6 hours after this chlorination. Then in fact we can use granulated activated carbon block. Then again already I told you that UV and this ozone that also be used. Then defluoridation, that's a big problem in 15 endemic states in India. So they are using activated alumina generally to remove the fluoride. So that can then again reverse osmosis is another method by which you can remove the fluoride. In Andhra Pradesh also there are many places they have this fluoride problem, especially in Nalgonda. I don't know whether it is presently under Telangana or Andhra. It's a maybe famous place for this fluoride issues. There actually, in fact, they have developed a method also based on their name itself, an Algonda technique, by which they are using this alum as a media for removing this fluoride. Then membrane filtration, there are micro, ultra, then nano filtration, reverse osmosis. All these type of things are there, especially to remove the salinity. But what they are using is that they are using a semi-permeable membrane by which the water is they are applying a pressure so that water is flowing to this type of semi-permeable membrane, so that only pure water, clear water is actually flowing through this membrane. We will be getting the pure water on the right hand side. The left hand side is a concentrated kind of things which you are not supposed to use it also. So that's the method by which you can give the or maybe convert the saline water into fresh water. And iron also is a problem in many areas, especially laterite regions. There are so many methods are there. We can oxidize to ferric hydroxide, filtration by sedimentation, accelerated by contact, and catalysis. Aeration is one of the best methods so that we can actually remove the iron and manganese also. And filters are also there, like using certain iron, maybe oxidized sand. We can actually we call it as a green sand. It is packed in a cylinder type thing. And if you are passing the maybe iron contaminated water, ultimately your water will be getting purified. So this is the method by which we can remove the iron. Then again, there's a technology available with the Institute of Minerals and Materials, Bhubaneswar. They had developed a filter media called terrafill media, which it contains actually red clay, sand, and wood sawdust. So it is having a maybe efficiency to remove the iron, and very efficiently it can actually remove the iron, which we are also tested in our laboratory. So this can be a good alternative to remove the iron contaminated water. Then water softeners are there, and that can also be used to control the maybe so hard water if it is there. And maybe summarizing this type of things, like maybe we have to improve the organoleptic properties using clarification, declaration, deodorization. And again, ceramic activated carbon can be used. And by removing the bacteria, we can use either boiling or a disinfection. Then maybe mineral composition can be improved by defluoridation, de-ironing, softening, desalination. So all these are some of the methods by which we can actually improve the water quality. Then actually, in fact, there are so many technologies are available, which include the advanced technologies, which you may also be studying some of these green technologies. But actually, the application is that, or we are actually considering the natural resources at the minimum kind of maybe chemicals which we are using, and it is having to minimize or mitigate the negative impacts on the environment from human activities. The applications include water and wastewater treatment, air pollution control, environmental remediation, wastewater treatment and management, then energy conservation. So all these are actually consisting of these type of green technologies. Now coming to the plants which are being used for water treatment, there are so many technologies nowadays available, which we call it as bioremediation to remove the contaminants or pollutants from the contaminated soil or even polluted water also. And like the plants are actually in fact helping the removal of this contamination using phytoextraction, rhizofiltration, phytostabilization, phytovolatilization. So these are some of the methods by which the contaminants is being removed. Phytodegradation is actually the compounds like organic compounds will be degraded to harmless product. Then phytovolatilization is the compounds will be getting volatilized. Then phytoextraction is from the soil itself. It will be actually taking out this toxic compounds. It will be deposited in the different parts of the plants. So then phytostabilization, roots itself will be stabilizing the compounds so that it will not be spreading into other areas. So these are some of the maybe examples like heavy metals, radionuclides can be removed by this accumulation. Mercury, selenium can be removed by phytovolatilization. Inorganic compounds can be removed by this phytoextraction. So all these are some of the methods by which we can use the phytoremediation, which are cost effective. Then we can actually the recovery and the reuse of valuable metals is possible by this method. It is potentially the least harmful method because uses naturally occurring organism and preserves the environment in a more natural state. So we have used different plans for the removal of these type of contaminants. So this is not very. You can even use actually the things which are available in your maybe nearby areas also. Like we have used another method also, like Eichhornia crassitus plants have been used. It's aquatic kind of species. We had actually applied certain electric current also. We found that the chlorophyll production is being increased and the system is actually having an efficiency of more removal of certain compounds, especially the heavy metals from the contaminated water. Like a cadmium, copper, actually, in fact, we tested. So another maybe the novel feature of this type of technology is that green infrastructure is actually coming to many countries nowadays. Actually, it is actually providing this ecosystem service to primary water management benefits. So there are so many technologies or maybe kind of what to say, some studies are being carried out world or regarding this type of thing. Like a green infrastructure is actually it can purify the polluted water from both the point and non-point sources by trapping containing sediments, pollutants, etc. Can protect the groundwater from contamination. So all these actually possible using this green infrastructure. Then green roofs are also coming so that over the building we can actually have this type of green plantation and can be completely covered with vegetation. So these are can be intensive or extensive. So that type of green roofs, this can remove number of air pollutants including particulate matter, oxides of nitrogen, sulfur dioxide, carbon dioxide, ozone, and also it can actually act as a storage for carbon also. An example of a Chicago green roof where actually they got plants for different types of plants are there on the in the roofs of this building, and this can actually act as a green infrastructure kind of a thing. So all these type of things are being maybe happening in many countries, so we can also adopt that type of things. And wetland restoration conservation. So wetlands are in fact can provide a significant support to traditional infrastructure for water treatment, water supply, drought mitigation, and flood control wetlands. So wetlands, we call it as the kidneys of environment, which we have. Like for example, East Calcutta wetlands. There is actually a kind of a natural sewage treatment plant. A large maybe sewage is being flowing through this type of wetlands that is being treated, and it is finally flowing into that water body. There are the similar kind of wetlands we can construct also. That is called the constructive wetland. The two types of constructive wetland is actually, in fact, one is horizontal, other is vertical also. Horizontal means that is actually flowing horizontally, another is vertically, it is flowing. So these type of things are being practiced in all over the world, and in fact, it is in many places in India, you can see that. So we also did a study on how to treat the or recycle the water or wastewater which is generated in our campus. So this is actually, in fact, side by side, we had a solid waste treatment unit also, whatever is solid waste generated from this particular area that is being treated also. Last 5 years, actually, it is being operated, and this has been constructed using ferrocement. And there are some pre-treatment units also there, like a settling tank, a skimming tank, a filtration tank, etc. The main treatment consists of constructed wetland, then the filter media, sand and gravel, and many types of plants, phragmites, and whatever locally available plants we can use for this type of recycling. So some of the stages of construction. The first tank is a sedimentation tank, which is actually whatever wastewater coming, and that will be sedimentation is taking place, and only clear water will be flowing into the next skimming tank, where actually oil and grease we have to remove. Filtration, actually the natural filter media which we are using for filtration. In the storage tank, then from the storage tank we are actually discharging that wastewater into that particular treatment tank. So that is the process of this constructed wetland. Different types of plants are being grown in that particular constructed wetlands. But the thing is that it has to be harvested periodically, then we can actually recycle the water. So this is the thing where actually energy is not needed. By gravity itself, it is flowing into the final tank. So the advantage is that we do not have to have any energy required for the flow of water. You can see that actually most of the parameters have a removal efficiency of around maybe 80 to 90%. But only thing is that we may have to have certain period of time, retention time, maybe up to some 24 to 28 hours for a maximum kind of removal. So these are some of the maybe concentration which we experienced. Again, we had experimented with a vermicomposting unit also, where actually, in fact, we used utilized African species to compost the waste, solid waste which is generated in that particular other unit, and having a very good type of maybe nitrogen and a percent of phosphorus, which we used for, or we are using it for as a biomanure. So this is the vermicomposting unit which actually, in fact, we fabricated in our campus. Again, we used a lot of other plant materials also for maybe removing even fluoride, nitrate, or maybe other types of contaminants like a cloud. That's we found that that is efficient in removing the fluoride material. Vetiver can actually remove even certain metals. Gooseberry can remove certain nitrate. So all these are actually having its own kind of maybe efficiency to remove certain maybe fluoride or maybe other type of contaminants. These are actually the efficiency of different types of maybe contaminants from the polluted water, And we used some type of maybe treatment units also for actually testing the efficiency of this type of contaminants. And ultimately, we developed certain filter media to with this type of materials we developed in our laboratory that has been used for removing the this contaminants present in the water, especially removal of fluoride, nitrate, etc. And we found that it is actually taking place through adsorption and interparticle bridging. Again, in fact, recently we did a study for an industry. So we suggested a retention pond for maybe with the ridges of different plant materials for actually passing that wastewater or polished water, so that finally it will be getting without which can be reused or recycled in the actually in the campus itself. This is a kind of maybe mechanism which we proposed, and they are actually in fact constructing this type of biopark using terrestrial and aquatic plants also. These are the different types of plants which we used to maybe plant along that particular thing. This is the maybe a sketch of that wastewater which is flowing around that particular area and the side of this area, which we proposed a lot of plants, and again aquatic plants also have been proposed. Ultimately, that will be purified and you will be getting the maybe 100% pure water which can be recycled and reused also. So we used so many other methods also to maybe endosulfan, as you know that pesticide, which in Kerala we found that it is very toxic, which have been used in cashew plantations. So we used so many methods like biological methods and chemical methods, and again nano phytoremediation technologies have been used to maybe degrade this endosulfan by using plant materials. And initially we used certain surfactants to wash away this type of endosulfan from the soil. Then in fact we studied using certain plants like using aquatic species and terrestrial species, how it is being used to maybe degrade this endosulfan. We found that all these plant materials have the efficiency to remove the contaminants or maybe degrade that particular endosulfan, especially the Salvinia monosta is having a very good efficiency to degrade. Maybe it is after 28 days, it is found to be maybe completely maybe contaminating this type of endosulfan or some pesticides also. So we used actually, in fact, other technologies also, not only these plants. We used certain microbial media also, like Pseudomonas bacillus also have been used. That is also found to be very efficient in removing the or degrading the endosulfan from the contaminated media, whatever, soil or even water also. So we found that this pseudomonas can actually degrade 98% of 119 microgram per liter endosulfan. So that is found to be one of the efficient method to degrade this type of maybe pesticide. And again, we used nanotechnology for different types of nanocomposites which have been used. Then mix of nanocomposites have been used. So these have been used to maybe remove lead, cadmium, and nickel, and also iron and silver coated doped zinc oxide nanocomposites have been used for the degradation of dyes and textile effluents. Magnetic nanoparticles have been used as a potential nano absorbent for maybe effective media for removing these type of things. Then again, a remediation of groundwater is also being attempted using certain maybe zero-valent iron nanoparticles. Then photocatalytic degradation also being done using titanium oxide films. So that is also being used or having studied in our laboratory for removal of degradation of certain organic compounds. Then toxic heavy metal removal by iron nanoparticles have been zero-valent iron nanoparticles have been attempted. And again, iron oxide impregnated activated carbon is found to be removing toxic metals like arsenic, lead, and chromium also from contaminated water. Then we have also maybe started some microbial synthesis of silver nanoparticles for the application of water treatment. And again, actually, the thing which you may be knowing regarding the water treatment is you should have a pre-treatment, primary treatment, secondary treatment, tertiary or advanced treatment, which you may be sometimes know. There are so many processes are involved in advanced treatment. Even municipal water treatment system require these type of things. Then secondary sedimentation activities like tripping filters. So these are some of the technologies which you may need in a wastewater treatment. So traditional and nowadays actually we are approaching a kind of a technology where we are actually focusing more on decentralized approach to treat the selected wastewater streams rather than integrated kind of things. We should have a decentralized approach. That is actually the all the world over it is being practiced. The advantage is that actually reusing the treated wastewater, we should do that in zero discharge strategies, minimizing waste generation, incorporate disposal cost to the holistic water and wastewater management. Again, actually, in fact, there are traditional technologies like coagulation and flocculation. These have been maybe removed by latest technologies using by activated carbon filtration, biological degradation, filtration technology. Then a disinfection or oxidation means oxidation technologies, an advanced oxidation process like ozonation, iron peroxide, with radiation from ultraviolet light. Activated sludge bioreactor, now it is being replaced by modular design approach. For instance, clarifier can be integrated within main aeration basin, which results in the minimal footprint. Chemical physical processes are being replaced by membrane biological reactors that also result in minimal footprint. Then the reverse osmosis as a tertiary treatment after a biological treatment stage. Then optimal quality achieved by reverse osmosis permeate keystone zero discharge approach. So this is something which I want to share with you.
Excuse me, sir.
Yes, yes, please.
Your PPT is not visible.
Actually, I had maybe concluded my this presentation.
Okay.
So any doubt is there, and I think we can actually raise any questions for regarding with which I presented.
Yes, sir. There are some questions. Maybe I can read those things, read those questions, and then you can answer one by one. So we are getting several questions. The first question is, what are the coagulants in purification of water?
The main coagulant is actually aluminum sulfate, which we are using called alum. Is one of the best maybe coagulant which we found generally using. And even industrial water they are using even iron sulfate, iron chloride also. Those type of coagulants are also being used. Even polyacrylamide also being used for this type of maybe coagulants in maybe several industrial units.
Alright. So the next question is, does boiling of water kills good bacteria? If yes, why it is the most efficient and simple method used by everyone? So
the thing is that maybe it is a little bit expensive because we have to use maybe a lot of fuels in boiling the water. Second thing is that when boiling the water, that will not kill all the maybe bacteria or maybe microorganisms. There can be some types of even virus or protozoa maybe there. So that will not be killed by boiling this water itself. No, that is why if you want to have a maybe 100% maybe very good disinfection, then we have to follow this ultraviolet radiation or maybe ozone. These are the best methods by which we can maybe recommend for the removal of that type of things.
Uh-huh. So the next question is how we can clean the acid rain water economically.
Acid
Rain water.
drainage water. Is it?
It is
Hello.
acid rain. Yeah.
Acid rain, no? Acid rain, in fact, maybe having a less pH, and you can, if that depends on the type of use also, no? If you are actually not using for drinking purpose, you can use the lime. Lime can be used to actually neutralize that water so that that pH can be raised maybe more than 7 or even 8 also. So that method is one of the cheapest method by which we can actually maybe control the pH of this acid rain. So if we can, lime powder is available, we can use that control the pH of that acid rain. But if you are using the for drinking purpose, there are actually neutralizing agents are there. Food certified these agents are available there, whereby actually we can use that type of neutralizing agents only. Otherwise, for a general use, we can use this type of lime only. Lime powder can be used so that the pH will be raised
Okay, sir.
more than 7 or something.
Next question is, sir, does water sources decreases in future? Probably he wants to know, like, if it is decreasing, what is the, I mean, how we can stop it or.
The sources means the water sources, no?
Yeah.
Water availability.
Yeah.
Water availability also already. And the first thing we have to do is that water available water we have to preserve and conserve. For example, if it is polluted, you cannot use that. So we have to be very careful that we are not polluting the water. And again, we have to be very maybe very careful that if a water is there, we have to, even if it is polluted, you may have to actually recycle the water. That's also very important. No? Water, like I already had an example of using constructed wetland, how you can recycle the water, reuse the water, and that way. So these are some of the methods by which we can actually use the water, recycle the water. Then groundwater recharge can also be carried out. For increase the water level of even groundwater. Then river water, no rainwater. You can actually have different types of technologies nowadays available to conserve these rivers also. The third thing is that you may have to conserve the wetlands, maybe open water bodies, whatever maybe, so that will also help in recharging the nearby water bodies. So if you are going to maybe destroy these type of natural kind of water bodies, again in the other water bodies also you will be maybe decreasing the water level. So you should never actually maybe destroy this type of open water bodies like wetlands or even ponds, water maybe. So all these have to be conserved and preserved. So once we are actually doing these type of things, then there will not be any problem, I think so. And also judicially we have to use the water also. You should not waste the water, and you have to be very carefully use that water, thinking that future generation also need this water. So all these have to keep in mind when we are actually using the water. That way actually we can actually conserve the water for the future generation also.
All right, sir. So next question is it okay to drink water with pH more than 7?
Yeah, it's okay. 6.5 to 8.5 is the maybe acceptable limit set by Bureau of Indian Standard. Up to 8.5, you can drink the water, no problem.
Okay, sir. So one more question is, what's the significant difference between purification and disinfection?
In fact, disinfection is also a method of purification, because disinfection, what we are doing is that we are killing the bacteria, pathogenic bacteria, what we call it as if a pathogenic bacteria is present in the contaminated water, if you are going to drink the water, there are chances of we are getting the waterborne diseases. Maybe one example is typhoid or maybe dysentery. All this can happen if you have maybe this type of contaminated water with the bacteria. Purification is actually what generally it is actually to remove the physical kind of maybe contaminants present, like maybe iron if it is present, then we call it as we have to purify the water. Suspended solids is there, we have to purify the water. So this is these are the difference between purification and disinfection. Disinfection is to kill the bacteria. Generally, purification is to remove the suspended solids or maybe other type of solids, salinity removal or even fluoride removal. All these are actually purification method.
All right, sir. So next question is, the present water purifiers add some extra minerals to the water. Are they good for health? And are the water purifiers are 100% efficient?
That depends on the company which actually manufacture. I cannot say that all are 100% efficient. So what some people are doing like reverse osmosis. The problem is that I already showed one slide now. The thing is that it is actually maybe removing all the essential minerals which is needed in the water, our human body also, when they are actually it is using a semi-permeable membrane. So whatever minerals are there, that is being removed when you are actually pumping the water through that type of filter media, and you are getting the pure water only in the second type of chamber. So that is why they are adding certain minerals, which is actually up to some regulations only they are adding that. But unfortunately, in India, there are no regulations which say that should contain this much amount of minerals in our water. But there are regulations are there available in either maybe Gulf countries. For example, UAE, they have certain regulations saying that your body or your water should contain this percentage of potassium or sodium or maybe chloride or something like that. But in India, there is not that type of regulations available in India, which says that you should have this amount of potassium available, because our water is actually having a maybe adequate quantities of all these minerals. So that is why we need not have to add the minerals until and unless we are using a reverse osmosis kind of a unit for maybe for a treatment purpose or removing this thing. So not only salinity, all the other things also will be removed when you are using a reverse osmosis unit. So where actually you have to use maybe this type of minerals which are being added to the treated water also. So I cannot say that generally all the companies are maybe marketing very good the filtration units. There are certain companies maybe there which are manufacturing with good one, or maybe they have their own problems. But the thing is that you have to test the water after purification. Then only you actually send the sample to a good laboratory. Then only you can be confirmed that that's a good company which we are actually using for this water treatment.
Sir, one more question is it possible to purify the water which come from melted ice caps, which consist of dangerous gases?
Melted ice caps, that depends on, it's a natural kind of thing, or maybe you are maybe mentioning about artificial kind of this thing, ice cap. Is it natural, like maybe some Antarctic or something like that, the Himalayan ice or something like that? The
One
question
more.
is not clear.
Yeah, the question is not clear. So one more question we got, which is, can we keep the water bottle for more time in sunlight? Because the student is saying that plastic could affect the health if we are keeping it
Yeah,
for more
that's
time.
very true. That's a very good question. But the only thing is that we are actually have to keep the water in a very maybe food grade plastics only, no, not the common plastics which we are using. Then you have to have some very high grade plastics, having a very good thickness. That if that will not having any problem, or even glass bottles also you can use, no issue. And you have to use a very good plastics only, not maybe common plastics which we are actually seen, which generally we are using. For example, for a packaged drinking water, you are using a plastic bottle. That type of bottle we should not use. You have to be very careful that we are using a very good plastic bottles. while maybe exposing to the sunlight. That we have to be very careful.
I think we are going to stop this question and answers because we are getting a lot of questions, and maybe we can conclude this question and answer session. So we can.
Okay, any questions from my students? It is welcome. You can maybe send to my email ID, and your professor is having my mail ID. If they have any doubt on these things, definitely they can send. And if some papers or something which they require on whatever I presented, that's also welcome. You can contact me at any time. I can share some of the publications also. Thank you.
Somakanta sir.
So respected speaker, Dr. P.S. Harikumar sir, dear faculty friends and dear students, a very good evening to everyone. So just now we all had an excellent treat of lecture by our invited expert, Dr. Harikumar sir. He thoroughly explained different methods of treatment, water treatment, starting from the very classical method to the very modern method. So I'm very sure that all of our students must have got very big boost from this particular lecture regarding their examination. Not only for their examination, I think a few of the students might have already thought about doing some projects over water treatment. So it's my personal view that after listening this particular lecture, all of us should be very much careful about, or we must think multiple times while wasting water. So on the behalf of the Department of Chemistry, VITP University, I sincerely thank to our invited expert, Dr. Harikumar sir, for readily agreeing to give a lecture in our EVS lecture series. So it was great to have you, sir, in our university in the EVS lecture series. Thank you very much, sir. Thank you.
Thank you. Thank you so much.
Thank you, sir.
Thank you. Thank you. Thank you.
Thank you very much, sir.
Okay, thank you.
Yeah.